This is lesson 5.2, problem number 14, done by Lauren, Sarah, David, and Cameron. So the directions tell us to find the coordinate of the orthocenter using these coordinates: J, which is 3, negative 2, K, 5, 6, and L, 9, negative 2. So first we want to plot J. We're going to count 3, 1, 2, 3, and then down 2. And then we're going to plot K, which is at 5, 6. So we're going to count 5. 1, 2, 3, 4, 5. And then up 6. And then we're going to plot L, which is at 9, negative 2. So count 9 to the right. And then down 2. And then we're going to connect the dots and make our triangle. So segment JK, and then segment KL, and segment JL. So in order to find the orthocenter, we need to find the altitudes, which are the length of the perpendicular line from a vertex to the opposite side of a figure. And we can find those by using the slope-intercept formula, which is y sub 2 minus y sub 1 equals m x sub 2 minus x sub 1. So first we want to find the slope of segment KL, which is negative 8 over 4. And then we want to find the perpendicular of that, which is 4 over 8, or 4/8, which can be simplified to 1/2. So we're going to use the coordinates of J, or point J, which is 3, negative 2. And then we're going to plug that into the slope-intercept form, which is, and we'll get y plus 2 equals 1/2 times x minus 3. And then once we multiply 1/2 by x minus 3, we get y plus 2 equals 1/2 x minus 3 over 2. And then we subtract 2 from both sides of the equations and get y equals 1/2 x minus 7 over 2. So then we want to find the slope, or we're going to plot or draw the line, the perpendicular line from J, which is right there. And then we're going to come back down. We're going to find the slope of segment JL. Now since segment JL is on y equals negative 2, the perpendicular slope would be x equals 5. And we're going to plot that. And then next we want to find the slope of segment JK, which is 4 over 1. And then the perpendicular slope of that would be negative 1 over 4. So then we're going to use our point L, which is 9, negative 2, and plug that into the slope-intercept form, which would be y plus 2 equals negative 1/4 times x minus 9. And then we're going to multiply 1/4 times x minus 9, and we get y plus 2 equals negative 1/4 x plus 9 over 4. Then we subtract 2 from both sides of the equation, and we get y, and we're going to plot that. So then, in order to find the coordinates of our orthocenter, we have to plug in x equals 5 into our y equals 1/2 x minus 7 over 2 to find what y equals, and then we can get our coordinates of the orthocenter. So we have y equals 1/2 times 5 minus 7 over 2. This is so we can find y. So once we multiply 1/2 times 5, we get 5 over 2 minus 7 over 2. And then after that, we simplify to get y equals negative 2 over 2, which then simplifies to y equals negative 1. Now, since we know y equals negative 1, and this is when x equals 5, we can say that the orthocenter, or the coordinates of the orthocenter equals 5, negative 1, which is right